And we're live. Welcome. This is a new series that we're starting about building a modern backend with TypeScript, PostgreSQL, and Prisma. In this series of live streams, and we're going to also have articles accompanying, we're going to be focusing on building a backend with TypeScript, Postgres, and Prisma. And in this first part, what we're going to do is we're going to look at how we design the data model and perform CRUD operations with Prisma. And if time allows, we'll also look at how to query aggregates using Prisma. So before we get started, I'm going to sort of cover what we have planned for the rest of this series. And I'll also share a link to the GitHub repository. So as you're all coming in, I see the comments coming in. Timo, Erickson, and Timo, great, wonderful that you're all joining us. So in this episode, we'll focus on the data modeling, CRUD, and aggregations. And then in later episodes, we'll talk about the API layer, validation, testing, authentication, authorization, deployment, and even integration with external APIs. This sort of came to fruition as a result of a question that we sent out about some of the aspects of modern web development and specifically backend development that many of you find confusing. And so we thought it would be a great way for us to see how Prisma fits into this. And so when building applications, one of the very, very first things that comes to mind is how to model the data. Almost all modern applications these days, they use a database and they rely on some form of persistent storage. And so how you model the data and how you understand the problem domain has a huge impact on how you actually develop the application. And so I believe that taking this approach of really understanding the problem domain first enables a really fluid process of development. So I'm just going to share the link now to the repository if you're interested in following along. Let's do that. Okay, so I just shared the repository, and you'll see that the default branch is part 1. So if you look inside, it's mostly empty. We just have the skeleton. For the application, we have TypeScript configured and a Docker Compose file, which we'll look at in a second. And yeah, so let's start with some of the prerequisites and some of the assumed knowledge that is necessary. So in terms of assumed knowledge, the series assumes basic knowledge of TypeScript, Node.js, and relational databases. If you're experienced with JavaScript but haven't had the chance to try TypeScript, you should still be able to follow along. And while the series obviously focuses on Postgres, most of these concepts apply to other relational databases such as MySQL and MariaDB. In fact, Prisma supports both Postgres, MySQL, and MariaDB. And then beyond that, there's not much prior knowledge that is required in terms of Prisma. That's something that we aim to focus on and really clarify in this series. If you want to follow the coding aspect of this, then you should have Node.js installed. And Docker is also very useful if we're going to be using it to run a development instance of Postgres. But I mean, if you have Postgres locally installed, that should work. Or if you're using a remote, like a hosted version of Postgres, that's also possible. Heroku offers a free Postgres database, which is just great for development, and I'll also share a link to that. Let's see. Okay, so I just shared a quick guide that we created on getting a Postgres instance on Heroku. Okay, so the starting point, as I said, is part 1, the part 1 branch of the repository. And now I'll share my screen. Let's see. Okay, so I'll add that to the stream. And it's hard for me to know whether I'm zoomed in enough. So please leave a comment. Also, if you have questions throughout this live stream, feel free to use the YouTube comments. That'd be a great way for me to adapt and perhaps cover things that I may have overlooked. And so let's start with the data model and the problem domain. So as I said, when building a backend, one of the foremost concerns is the problem domain. And by problem domain, or it's often referred to also as problem space, it's just a term referring to all the information that defines the problem and the constraints and the constraints on the solution. And so by understanding the problem domain, the shape and the structure of the data model should become clear. And so today what we're going to focus on is a grading system for online courses. What does that mean? It just means that we're going to be storing users, we're going to be storing courses, and each course can have multiple tests. And then for each test, we can have multiple test results. So if you're familiar already with some of the relational data modeling concepts, you can probably already see some of the relations here. I've created a diagram using this really nice tool called DB Diagram to visualize that, which I'll just share on the screen. And so we have here the data model that I created that should represent the problem domain that we have. And so all of these lines might be already confusing. These are what we call foreign keys. But the idea is that we start off with entities. And an entity is really either a physical object or an intangible concept. For example, a user represents a person, which is a real physical thing, whereas a course is a rather intangible concept. Let's talk a little bit about how this model looks like. Let's start with users. So a course can have, a user is a person with an account, and a user can be both a teacher or a student through their relation to a course. That means that if you have a user account in this system, that user account could either be, simultaneously a teacher for one course or a student and a student for another course. And we'll see how we model that with the database. You can probably already see the course enrollment table, which creates essentially a many-to-many relationship. So that was the user, and then we have the courses, and I mean, a course, this might even be a course. Okay, I will zoom in. I'm getting some feedback here that it's not big enough, so I hope you can see this now. Let's see if there's any other comments. Okay, yes. Oh, sorry about that. Please increase the zoom. Please zoom in. Okay. All right. Let's see if this is any better. Otherwise, what I can do is I can zoom even more. All right. Oh, okay. Has some built-in. Great. Okay. I hope it's fine now. Someone asked if it's pre-recorded. It's not pre-recorded. We're live. Great. Okay, now we can continue. Thank you for that. Okay, so we had a course, and then a course can have multiple tests, and each one of those tests can have multiple test results. And each of those test results actually has more than one relation. So in this case, a test result has 3 relations. The first one is grader ID. That is the identifier of the teacher, essentially, who graded the test. And we have the student ID. The student ID obviously represents the student who sat the test. And then we have test ID, which links that test result to a specific test. So if a single student is part of a course, he will have to take multiple tests. And we need to be able to link each test result with each test. Then, as we saw, a single course can have many tests, and this is even nicely visualized here. If you can see the 1 and then the star next to the course ID field. And similarly, I mean, this applies to all of the relations in this diagram. I'll also share this link because I think it might be useful if you're following along. Also, a nice thing about this DB diagram is that you can export your database schema from Postgres and import it in, and it'll just visualize it for you. And I'm a visual learner. I think many of you out there are also. Okay, we're still getting some complaints about being unable to see. Let's see what I can do here. Okay. Timo Müller, I can hardly see anything. Okay, I hope this is a bit better. Otherwise, I've shared the link. And Bram also asked what's the name of the tool that I'm using. So it's called DB Diagram, and I just shared a link. And then we also had a question about, is it possible to do aggregations from Beratna? And the answer is yes. We will hopefully, if we have time, we'll get to that today. That's the goal. And let's see if there's anything else I can do to improve the quality. Okay, I've got an idea. I'm going to just reduce the resolution of my screen. Let's see. And let's try to make this a bit bigger. This should maybe be a bit better. Otherwise, you can just open up the link that I shared, and that might help. Okay, cool. So, and we had course enrollment. So I think, so we spoke about courses, tests. So a course can have multiple tests. Each test can have multiple test results, and each of those test results will be associated with a user for the teacher who graded it and for the student who sat the test. And what's really interesting is the way that this relationship between users and courses works. So this is what we would typically call the many-to-many relationship. And some of the examples in the wild of many-to-many relationships are, let's think. So blog posts, and in a blog you would typically have tags. And so each blog can have multiple tags, and each tag can be used in multiple blog posts. And so similarly here, a single user can be associated with multiple courses, and each course can have multiple users, either students or teachers. And so this course enrollment table will allow us to create those links, and this is what we call a relation table. And what you will see is that this relation table actually has an extra field. So this extra field is called user role, and that's just an enum type of either student or teacher. And so through entries, through records in this table, we're able to associate multiple teachers and multiple students to a course. Now, done most of the work here in terms of designing the data model. And now let's look at how this would be done with Prisma. So with Prisma, we have this idea of a Prisma schema. And a Prisma schema is a declarative configuration for your database tables. Under the hood, we're going to use Prisma migrate, which will actually use the Prisma schema to create the tables in the database. And then sort of similar to what we did with this entity diagram here, we define in the Prisma schema columns and relations between database tables. So let's hop onto the, let's see if we have any, let's hop onto the code editor here. And so if you open up the schema, trying to make this as big as possible, you'll see that we have these 4 models. And so with Prisma schema, each model maps to a database table. And so as we had in the diagram, maybe I can have it here on the side, we had 5 of these tables, and as you see here, we only have 4, so we're actually going to need to add another one, and we're going to call that course enrollment. And as you see, I'm getting these red squiggly lines. This is thanks to this wonderful extension that we have. Shout out to Carmen for really having polished it recently, and we're getting a lot of really nice features. So if you're working with Prisma, I highly recommend this for VS Code, and hopefully in the near future we'll have this also for other editors. And so this gives us a lot of syntax highlighting, code completion, and formatting, and most importantly probably is linting. So this will help us to figure out some of the mistakes as we go along. And so here what we're seeing is an error validating model, and what it's saying is that it needs to have at least one unique criteria. And that would be typically represented with a primary key field. So we're going to look at that in a second. Also, if you're following along and you clone the repository, what I did is I added a schema.solved.prisma in the Prisma folder where you can already see the solution. So if you're interested in already getting the meat of it, feel free to check that out. Otherwise, I would recommend actually that you just follow along and see the process of creating that. So let's look a bit at user. All right, so the first thing we need is an ID field, and that will be of type integer. And I'm already getting here, I think it's an int. And then here we're going to actually set a default value, and we want to actually auto increment it. So I'm really relying here on a lot of the auto completion, which makes life much, much easier. So this is really, I mean, having come from a background working with a lot of SQL, this is a bit of a breath of fresh air, I would say. Okay, so we've defined the ID field, and then we have the email. The email is of type string. And what you see here is we have the option of adding a question mark. A question mark would actually make this field optional, but we want the email to be required. This will also help us later to do all sorts of relations. And we'll get to that. And with this, I'm just going to comment this because all of these red lines are giving me a bit of making me a little bit anxious. Okay, so what do we have? Okay, and I just used the format command, which aligns it nicely. And then here we want to add a unique constraint. And so we have the ability here to define all sorts of different field attributes. And in this case, we want a unique constraint. And whoop, it's already happy. I think I also forgot to, so the reason that it's squiggly before even defining the email field is because we need to define one unique field, which would either be a unique field or an ID field. And since the ID is the ID, we need to add this ID attribute. And now we add the unique constraint. Actually, the unique constraint will also add an index, which is really useful. I mean, because a lot of the lookups that we'll end up doing in the CRUD part of the application. And just in case you're not familiar with the term CRUD, CRUD means create, read, update, and delete, which are the sort of the 4 typical operations that you do with a database. So when doing CRUD operations, when doing lookups, being able to look up via search the user table by email will give us the result pretty fast. Otherwise, it has to do a full scan. And so with an index, the database is able to pull that record very quickly. Okay, and now we have the first name. which is also a string, last name, string. I'm a bit used to surname, but I've sort of gotten adapted to last name. And then we have a social field. The social field will be a free-form JSON field. And the reason that I'm using JSON for this is so that I can easily, I don't have to adhere to a schema. So by having this data, by using the JSON data type, it's very flexible. So I mean, if there's a new social network that pops up, we can add fields as we like without having to do a database migration. Typically, when we work with relational databases and we want to add new fields to tables and so on, we have to run a database migrations, and essentially that's what Prisma Migrate is for. It solves this migration problem. And I should point out that while Prisma Client is already in general availability and is production ready, Prisma Migrate is still in experimental state. It works, and we're going to be using it. But there's a lot of work being done right now by the engineering team at Prisma to improve that. So we have this social JSON field, and I'm not going to even define any of the relations yet. I'm just going to define the fields for each one, and then we'll slowly go through the relation fields. And so for a course, we have an ID. In fact, I can just copy this line here, and we have an ID. It's also automatically incremented, and it's worth pointing out here that MySQL, for example, in comparison with Postgres, has slightly different syntax for defining this auto-increment behavior. And one of the nice things of using something like Prisma is that it abstracts a lot of the database-specific details. And so this would work with both MySQL and Postgres, and it would implement it with the database-specific details. Another thing I should probably mention is this data source block. This essentially defines the kind of database that you can use, and as you saw, I use control space here in VS Code to get the auto completion. So we're using Postgres, and then this env thing here that will essentially, so you can pass a string here and then use Postgres and pass the whole database URI. But typically, because the Prisma schema is committed into a repository, we avoid committing secrets into a repository, and so that's why we use this env command to load it dynamically. And so what we need to make sure, and we'll get to this a bit later, is that we have this database URL environment variable. There's two ways to do that. You can define it just as a plain old environment variable. I'm using fish shell here, but if I were to just open up Zen shell, which has a more standard syntax for that, that would look something like database, export database URL, and so on and so forth. Yeah, alternatively, so that was the one option, and then the second option is to have an env file inside the Prisma folder where you define the database URL. Let's see, I'm going to pause, go back to the schema. And I'm going to pause here and just look at some of the comments coming in to see if there's any questions. Okay, there's a lot of comments about the resolution. I'm sorry about that. We'll see what we can do. This is from 646. Yeah, I guess the diagram didn't really work out too well, but I've shared the URL so you can go to that. And I'm just going to close this now, or I'll just move this to the other screen that I'm using here. And then let's see. Okay, someone's asking about Docker Compose. This is beyond the scope of, using Docker Compose for Prisma Migrate. Maybe we'll get to that. Thank you for that request. I forgot the idea. Oh yeah, thanks, Drigo. Yeah, luckily we had linting here to solve that. And then we have another question. What would the created at and updated at fields look like for automatic for automatic updating. So I'll just show this, and then I'll show you how that can be done. So what we can do here is we can do updated at and do a date time, and then do default, and then we have this updated at, but I believe that I didn't do that correctly. I think it's that. 90% sure that's the correct way to do it. Nope. Updated at is different, so correction, that is the correct way to do updated at, but created at is also a date time, but what it will use is it will use a default, and then here we can use now. And so that's to answer your question. I'm going to remove the banner now. Is it possible to have a JSON array field? I'm not 100% sure about this, but I believe that it's possible looking into this. Also, I'm going to just open up the Prisma docs just so you have this. Prisma docs are really, they're getting a lot of love recently, and so I highly recommend that you check it out. And let's see. So, by the way, JSON is a field, is a data type that we recently added. And we have a lot of different documentation. So let's see if there's, okay, so here there's an optional JSON field. But based on it passing the linting, I would say that it is possible. And perhaps at some point we'll get to that and test it out. So thank you for that question, Ayush. And so let's continue. I'll even leave the created at and updated at for the fun of it. I think we also have it created at. Yeah, I think we have it on other models, which we'll get to. So I'm just going to remove it from here for now. And then back to the course. We had the ID for a course, and we had a name, and that's just really a required string field, plain text field. We also have course details, which might be, you know, if we have the course name, then course details might be a bit longer. And so we'll have a string for that. And I'm using the shortcut. So this, what you saw here was the shortcut for formatting the schema as you go along. All right, so we have the course details, and that's it basically for a course. I mean, besides the relations, which we'll get to. And now we get to test. And so a test will have an ID as we had before. Always a bit fun with a bit of good old copy pasta. And then a test also has an updated at. This might be relevant in the context of, say, a test changing its date. And so it's really interesting to see when it was updated. And by using the updated at, whoops, sorry, that was a date time. And there we go. And we also have a name for the test, which is a string, and a date, obviously, which is a date time, but doesn't have any default value. That's something that's will be user entry or entered via programmatically as we sort of get into the business logic aspect of this application. And then we have the test result. Test result is quite interesting because it has three relations, if you remember from the schema the data model that we created. Where do we have that? Yeah, so we had the three relations. So when we get to the relations, it'll get quite interesting. So for a test result, we first have an ID. And we have created at, which is date, time, and default now. What was it now? Result. We have different data types, and we can represent that as a float, but to avoid a lot of the floating point arithmetic, I decided to just use an int and then represent that essentially as a percentage precise to 1 decimal point. So it'll be represented as, so I'll make a comment here, and precise to 1 decimal point, represented as result times 10 to the power of -1, and that just is a fancy way of representing. So if we have, well, that's not a good example, but if we have 956, that's actually 95.6. Okay, we had the result, and that's pretty much it for the scalar fields. So all of these fields, we consider them scalar fields. I'll remove the JSON array type from the social. Yeah, and so all of these fields are what we call scalar types, and they're just basically implemented as native data types in the database. And I'm going to pause here and look at some of the comments to see if there's any questions. Okay, Prisma docs are awesome. Thank you, Bram. That's really nice to hear. Are you going to be covering authentication? Yes, we will be covering, however, not today, as that's beyond the scope of today's live stream. Okay, Prisma migrate doesn't seem to work with JSON array. So thank you for pointing that out. Actually, I will probably relay that this to the engineering team to get maybe their feedback on this. Perhaps someone is also live and can chime in. And Wesley asked a question. In relation to fields of type byte A, any predictions? Not sure that I understood the question. Perhaps you can share a bit more about your use case and then we can answer that. Also remember that, so we have this chat for this live stream, which is a good way to interact sort of on a more immediate basis, but we also have a very active Slack, so if you want to join us on Slack, you can go to slack.prisma.io where you can sort of get an invite. And you can also check out, there's a lot of interesting discussions happening there and a lot of really interesting use cases that people are using Prisma for. So we now have 42 viewers live. It's really nice to have you all here. And now let's move on and define some relations. We ready for some relations? All right, cool. So let's do the difficult part first, which is the many-to-many relation. In general, there's two types of many-to-many relations that you can define with Prisma. We have what we call an implicit many-to-many relation, which would look something like this. So we have the many-to-many between users and courses, as we said before. And so what we could do here is we could give it a courses field, and then when defining a relation, typically you point so the data type for the field is just another model. And so in this case, it'll be course, but remember that you can have multiple courses. It's a many-to-many. And that's not all of it, because we also have to define the relation on the other model. And so here we'll have members. And the reason that I'm using members rather than students or teachers is because, we will get to that in a second, but because we can have essentially both students and teachers, both of which are users, which will be related. So we have members here, and then the type would be user, an array of user, which is essentially the way, this is how you define an implicit many-to-many relation. However, there's a problem with that, and that is exactly what I said about this user types that we want to have. And this isn't, so in an implicit relation, what Prisma will do is it'll actually create this relation table that we saw in the diagram, this course enrollment table. That will be automatically created by Prisma. But since it's implicit, we don't have a way to customize it. And so we have to use an explicit many-to-many relation. And so for that, what we're going to do is we're going to define a new model that's called the model, the course enrollment model. And in this course enrollment, first of all, I want to have a created at. Why? Because it's always nice to know when things were created. Essentially, we can think of the created at as the time when either a student or a teacher joined the course, which could happen at any point, perhaps throughout the life cycle or throughout the duration of the course. And so the created at is date, time, and it has a default of now. Whoops. Okay, we're getting the squiggly lines because we still don't have a unique field. And we will get to that in a second because I don't want to define another identifier. There's another really cool way to do that, a cool sort of SQL way to do that, and that is a multi-field primary key, which we'll see in a second. And so we have this, and then the main thing that we care about is this role, because through the relation between a user and a course, we want to denote which role does this user have through his association with the course, either a student or a teacher. I hope I'm not repeating that too much. But I'm going to define this user role, and obviously it's telling me, hey, user role doesn't exist. But I have this nice quick fix feature here, which allows me to create a new enum. And so, like magic here, I can define the different types of users. And so we have student and we have teacher. Okay, but we still haven't defined the unique ID field. And now comes the part of the relations. So let's bring this up closer to the user and courses. Exactly. I'm going to make this a bit smaller. I hope it's not too small. I'm also pausing to go back to the questions. Any possibility of 1080p streams? As far as I know, it's not possible with the technology that we're using. But if you've joined just recently, I should point out that we're going to have also an associated article which covers everything that we do here in detail, which you can also follow at your own pace. So I'm sorry about the 1080p, but we'll try to figure out something for the future. And JSON type, JSON arrays also work. We'll see about that. But and then is geolocation data type supported? No. So currently it's not supported, but this is an often requested feature, and there's a lot of work being done on getting more native data types supported. So this is one of the initiatives that's going on right now. If you have these type of questions and you want to maybe submit a feature, then you can always go into the Prisma GitHub and you can search here. Oh, there we go. So we already have an issue supported. So generally, if you have a feature that you care about and you want to get it sort of pushed, it's always good to go here and give it a thumbs up. And also perhaps detail your use case, you know, like working with geotypes and spatial data types. It's there's a lot of like very specific details that need to be covered. So it's always good to have as much context as possible when you do this. So thank you for that question, Vamshi. And now we're back here. So okay, now let's define the relation scalar fields. And so we care about the user ID, which is just an int. And we care about the course ID, which is just an int. And we also need to define the actual relation fields. So these are the relation scalars. And then we have the relation fields. And the relation fields are relevant in terms of the way that you interact with Prisma Client, as we'll see. And so here I want to define user, and it's of type user. And then I'll use this relation attribute here to denote that this is associated with a field. So fields, and then here we want to have user ID, and then references. And in the references part, what we do is we actually tell it which field is it referencing in this user model. And so because we're using the user ID, in this case, we'll look which one do we want, the ID field. Worry not about the squiggly lines. We'll solve that in a second. And then we also have the course, and the course is of type course, and then it's also a relation field, and the fields are course ID. There's different styles about how to order these. I generally like to have like the relation scalar, in this case, user ID, right next to the relation field. Some prefer to have the relation scalars at the top. I don't think it really matters. It's just one of those taste questions. Okay, so we had the fields course ID, and then we have references, and then in this case it also references the ID. And so we're still getting, because we don't have any primary key on this, any primary key or any sort of unique constraint. And now I will define using @ID. @ID allows me to define a multi-field primary key on a table. And then in this case, so a primary key has to be unique. And then when we're doing multiple field, like a compound primary key, the combination has to be unique. And so in this case, what we want to do is we want to do that on the user ID, course ID, and the role. And just formatted it, and the squiggly lines are gone, so we're in good shape. This constraint, essentially what it does is it limits the ability to associate users to courses with a single role. So, for example, if you have Alice with user ID 1, she can only be associated to a course with a single role. What it also means is it means that theoretically, in this data model, what it does support is it supports having users being members of the same course with different roles. So that means Alice could be associated with the same course, once as a student and once as a teacher. And this is actually not a bad thing. Otherwise, if we had removed the role from this compound primary key, we would only be able to have the user associated once with a course, so we wouldn't have this ability to do association by multiple roles. Okay, I think we're pretty much done here. I'll remove these to-dos. If you're wondering where the highlighting for the to-dos comes, I'm using an extension for that. And I'll pause now and look at some of the questions that may have come. Okay, Adam Tuck, MN relations, so many-to-many relations confuse you. Yeah, I feel you. They are a bit confusing. I highly recommend checking out some of the docs that we have, and hopefully also this series, as we'll get into some of the details, and the CRUD implementation will be able to look at that. And then thank you for the compliment. Prisma is awesome from Dubu Lab. Okay, let's continue now. So we've defined the Prisma schema and all of the models, and we talked a bit about the relations. Implicit and explicit relations. I think actually I haven't covered all of the relations. It was just for the course and the course enrollment. Oh, yeah, right. Yeah, we still need to define the rest of the relations. I'm sorry about that. We can leave those comments in. Okay, so what actually happened was this was automatically added by the formatter, and the reason is these relation fields are required on both sides. And so, I'm a little bit confused myself for a moment. Let's see. Oh, right. That's because we still had these, the implicit relation. So we're going to remove the implicit relation. And so actually what we see now is really the difference between this implicit and explicit relation. In an implicit, the models just point to each other, in this case, user to course, but we decided to go for an explicit relation. And so in an explicit many-to-many, the relation fields on the two models will always point to the relation table, in this case, course enrollment. And the name can be always renamed to fit your use case. In this case, I think a good name for the association on the relation field of a user would be courses. And then for a course, we can just call it members as we did before. I just formatted that. Okay, so we have this explicit many-to-many relation, and now let's look at a bit at the relations of tests and test results. So first of all, a course can have multiple tests, and so a course can have many tests, and then in this case, the many side will have a relation scalar field pointing to the one relation that it's referring to. So in this case, course ID is just an int, and right, and then we have the normal relation field, which is a course field, and we need the relation attribute here, and then fields, and then we're referring to the ID. Whoops, I think there's no need for the quotes, and references, whoops, sorry. The fields is the course ID. Right, so references, and then here we reference the ID field. And what you will see is that the course should automatically get this tests field. So in this case, we'll have here, a course will have tests, and then test, and then it can have many of them. So pausing there for a moment, we had this tests field, essentially, that says a course can have many tests, and then a test can be associated with a course, and then we do that here with the relation scalar. And this relation field also will allow us, as we'll see in the CRUD side with Prisma Client, to get from a test to its associated course. And so this field is mostly useful for the interaction with relations in the Prisma Client. Okay, now we have test result. That's also an interesting one. And a test result, we can have many of it associated with a test, and so we'll have here a test ID, and that will be of type int, and then we'll have a test relation field pointing to test, and relation, and as we did before, fields, test ID, and then references ID, and then this ID is actually pointing to the ID field of a test. And ta-da! I don't know if you saw that, but the moment that I formatted it, the formatter automatically added the other relation field on the test, and then we can rename that to test results. Like generally, the name used here is also the name that will be used in the Prisma client, and so it's very useful to follow camel casing, I believe it is. I mean, starting with a lowercase, just to stick to the some of the JavaScript and TypeScript conventions. Okay, cool. So we define one relation of a test result, but we also care about the student that a test result is associated with, in addition to the teacher who graded it. And so let's add a student ID here of type int, and a let's do it one by one. So student ID, and then we have the student. So remember, one-to-many, many-to-many, you always have, well, let's talk about one-to-many. So we have this one-to-many relation between test result and a user. And so typically there will be three fields, two relation fields on the two models and one relation scalar, in this case, on the many side. So there's many test results per user. And so the relation scalar goes here, and then we have the student. And the student is of type user, and it's a relation field. Fields are student ID, references ID, and then this is the ID field on the user model, which is defined here. Let's see. And then we want to do the same thing essentially for teachers. So I'll just copy that, and then greater ID, and then graded by will be the name that I'll call it, and then that actually is using the greater ID relation scalar field, and it references also ID on the user model. And here what we're getting is an error, ambiguous relation detected. Okay. So in such cases where we have two relation fields that are pointing to the same model, we have to disambiguate that. And so we do that just with a simple name field. So I'll just name this results, and then here I'll name that graded. And error validating model, automatic related field generation would cause a naming conflict. Okay. I think this might be related to the, let's see. So we had test ID. Right, yes, that's because we need to also have the relation field on the other side. And so let's do that. So test results of type test result. You can have many of them. And this is a relation, and we actually need to tell it here the name. So in this case, it's the test results which are associated with the student, and so we'll use the same name that we used here. And we'll also have another field, another relation field called test graded. Test results, and then it's tests graded. And let's see if auto completion picks that up. No, it doesn't, but we can just put the name here. And let's see what we're getting here. This line is not, oh yeah. I think I may have added double brackets here, and so that's why we're getting that. Oh, okay, there we go. Nice. No more red squiggly lines. All right, so we've defined all of these relations. Let's see if we've missed anything. Also, I'm going to put this enum down at the bottom just for. And I usually like to add a comment before, and we're already at 7:24 Berlin time. Let's see how far we get with this. Yes, this is all Prisma 2. Nicholas, why is course enrollment MN, but test result isn't? I believe that that's because, so course enrollment is this explicit relation table, whereas test result, if we go back to the diagram, it's the many side of a one-to-many relation. And it's a one-to-many because well, it depends on the context of which relation we're speaking of, but in the context of all of them, it is a one-to-many. So one test can have multiple test results, but one test result cannot be associated with multiple tests. That is the reason to answer your question, Adam. Okay, so we've defined this nice data model, and we have this full schema here. Let's see. And I'll just clean it up a bit here. And wonderful. So we have courses, test results, and test graded. Great. Okay. I think at this point we're ready to carry out the migration. So I'll open up the terminal. I've got the terminal hopefully big enough here. I'll zoom in even a little bit more. And I'm going to run my Docker Compose up, which will get the database running. So I have this database. If you're interested in how that's configured, I'll just quickly show. So here, I'm just defining I'm using the Postgres Docker image, and I have these two environment variables so that it's easy to connect. And these also correlate with what we have in the env. So, and then here I'm pointing to this grading app database, which I haven't even created. And yeah, so we have the database running. And so let's talk a bit about how Prisma Migrate works. Generally, when working with Prisma Migrate, there's two steps that are required to run a migration. The first step is saving the migration. And in this step, Prisma Migrate takes a snapshot of your schema as it is at the moment that you use the Prisma Migrate save command. And it figures out what steps need to be carried out in terms of altering the database, really all the alter SQL commands. And when you run this, an artifact is created in the Prisma migrations folder. So here we have this Prisma folder. It's currently empty. And so let's run it. So npx Prisma migrate save, and we need to give it the experimental. As I pointed out earlier, Prisma migrate is still experimental, but it's also really nice, and in the near future there's a lot of work being done on it. Just gonna get some water. Okay, so we had this experimental flag, and that's pretty much it. And it's detecting that this database doesn't exist, so I'll just let it create it. You don't even need to define the name of the migration. You can just go enter, and it'll automatically give it a name. And as you will see now in the Prisma folder, we have this migrations, and so I can even run a tree on Prisma, just so you can see all of the files. So it has these steps, and then a snapshot of the schema, and also a README file. Okay, now let's run the migration. We can do that with npx. In case you're not so familiar with npx, npx is just a way to call some of the local dependencies that you might have as like a CLI tool. And so in the package JSON, we have the Prisma CLI here. And so that has this Prisma command in it. So bx Prisma migrate up experimental, and woo. Okay, so it created the database, and I'll give you, if you really want to make sure that it's done, there's a couple of ways that we could look at whether the database has been created. I am a fan of PGCLI, which is a fancier version of the Prisma CLI, of the Postgres CLI. And what did we call the table again? Let's see, in the end file, it was grading app. And so here I can list the tables, and there we go. We have all of these different tables. We can actually look at one of them. It needs the quotes, and so we have this, course details. Let's look at the user table. And what we can see here is these are all the relations that we defined. Let's look at course enrollment. And here we can see, I don't know if you remember, but we had in our schema a multi-field primary key. And so that's what we see here in this line. So great. We have our database created, and now we're about an hour in. I think I will continue so that we can look a bit at the Prisma Client aspect. What we'll do is, our goal is to create a seed script that will fill the database with data. And so I've already created a skeleton here, and the important thing to point out is that, first of all, this is a TypeScript file, but as you'll see, you won't have to define a lot of types because Prisma Client is actually is generated in TypeScript, and so you have all of the types here which can be inferred by the TypeScript compiler. So we have this Prisma Client, and then we're doing two operations with it. Here we're just instantiating it, and Prisma will be the main object that we use in order to interact with the database. Oops, copied the wrong thing. And then lastly, we call this disconnect function. This is necessary. If you don't have this and you run this script, it'll actually keep the event loop won't be empty, and then the script won't exit until you sort of give it a control C, an interrupt. And so it's generally good practice to disconnect at the end of a one-shot TypeScript. Otherwise, there's obviously, when deploying this to the cloud, whether that's a serverless platform, there's other details that come in, but let's focus right now on this seed script. So let's try to fill the database with some data. And before we do that, let's talk about Prisma Client. So we looked at Prisma Schema. That was this declarative definition of our data model. And we looked at Prisma Migrate, which uses that in order to create the database. And now we'll look at Prisma Client. Prisma Client is the type-safe, TypeScript, auto-generated database client that is essentially tailored to your data. And we need to have, we need an additional block here so that we can generate this client. So this is what it looks like. Generally, it would just look like this. And the idea with this generator is that you can generate clients from multiple languages. Right now, we only have the the TypeScript, which is essentially production ready, but we're also working on a Go client, and so here you would be able to define that. And then we also recently introduced this preview features, which allows you to enable some of the it's sort of a feature flag for some of the functionality that we want to deliver, but we're waiting for feedback. So initially, we put it in this preview features. We hide it behind this feature flag. And if you look also, if you're interested in following some of the new features coming in, you can also see that in the Prisma releases. So we have these preview features. And so we recently introduced distinct, and we recently introduced middlewares, and there's a lot of interesting things happening there. But what we're going to look at specifically is the, let's see, where can I get all of the releases? We're going to be using the aggregate. That should be our goal. So we have this aggregations API, which essentially allows you to do things like group by and min, max, average, and sum, and so on. And so this would be relevant in the context of our real-world grading app, because we might want to get, say, the average test result for a student who may have been part of a course and sat 3 exams or 3 tests. And might want to see the minimum, the maximum, or we might want to see even the average for a specific test across multiple students. So we'll be able to do all of that. And what was it? The aggregate API, that was the name of this preview feature. Okay, so with this generator, now we can go on and generate this client. And the command for that is simply, oh yeah, npx prisma generate. And there we go. So that's been generated. And now we can go into our seed script. And let's start by creating a user. So all functions, so most of these operations are asynchronous in the sense that you have to communicate with a database, and so that's what we use that's why we defined here an async function. And let's create a user. So let us create a user, and maybe that user will serve as the teacher of the first course that we introduce. So Prisma, and then here what we have is so all of this is typed and the code is being generated based on our schema, and so this is really nice because it just gives you quick access. You don't need to do copying, pasting, and you really get everything is typed, so you get a lot of annotations and help as you go along. So here we want to create a user, and so we have multiple functions here, but we just want to create one. And then we get a lot of information. I'm going to pause here and see if there's any questions so far, because I've been running through a lot of details. Okay. Let's see. We have 24, so we lost some listeners. That's okay. Thank you for everyone who is still with us. Basically, an explicit many-to-many relation is defined by join to one-to-many relations via link table. Not sure if I understood that, but I get the feeling that it is correct. Okay, let's go back to our user creation. And so here, every time I do control space, I really just get all of the auto completion, and so we care here about the data. And so let's start with an email. Let's see. Let's say our teacher is Grace and she's using .com, first name, and let's add some social info. Here we can add anything, so maybe she's using Facebook and maybe Twitter. And so we have all of that. And that's about it. Now let's run this. I'll open up my terminal. Gonna make this big, and I'm using TS Node here to run this. Okay, well, how do we know that went well? Well, there's a couple of ways. We could open up the Postgres CLI, and I can just connect to the grading app, and then select Q from user. Let's see. Oh, yeah. There we go. So here we have this record that we created. Alternatively, if you're not so crazy about using the CLI, there's a couple of options. We could just log this. And then what I expect if we run this again is that we will get a unique constraint. And let's test that to make sure that it's all correct. And indeed, we do get an error here. Unique constraint failed on the field. So because this is a seed script, this is probably not something you should do in production, but because we're going to be running it a couple of times, I'm just going to do a delete many. And so if If you delete many without passing it any options, it won't actually allow you because it expects arguments, but you can just sort of bypass that by passing an empty object. Again, not be done in production. And then let's run this again, and then let's see what it logs out. And so we get here this ID. This is the ID of the newly created user. Wonderful. So we created a user. Now let's get to some juicy stuff. Let's get to creating a course. And what we're going to do is we're going to also create a course with nested relations. So in a single command, what we're going to try to do is we're going to try to create a course and 3 tests that are associated with that course. And one of the nice things with Prisma, when you do these nested writes, first of all, it's all encapsulated within a single transaction, which is a really good way to guarantee that either everything gets written or nothing gets written. So let's take a look at that. So let's create course is equal to await prisma.course.create, and then we have this data object here. And so here we can already start seeing some of the fields that we can add. And then let's start with a name. CRUD with Prisma in the real world. And now we have this tests field. Is that correct? Let's see. Let's see if the auto completion helps me here. Oh yeah, I think I need to add a comma first. Yeah, there we go. And so tests, pass it an object, and then we have 2 options here. We have create or connect. Connect allows us to connect an already existing course, test to this course that we're creating, but in our case, we want to create. So we'll create, and then here we can already pass all of the fields for the tests. I'll just open up here the schema just so you can really see that. So a test has these 2 required fields that aren't automatically created, and so this really maps. So date, and I'm just going to use these date functions to these date functions that I have up here in order to create a bunch of timestamps. And so I've already prepared that. So here we have just 3 timestamps. In fact, I think we should be able to see the type. Yeah. So it's able to infer the type. And so we want to create, but actually we don't want to just create one. Let's create multiple. So you can just pass an array here. And I think this should, there we go. So if I remove that, I can pass here an array, and then an array of objects, and then each one of these objects needs to have the date. So let's do 1 week from now, and we'll give it another field of the name, which will be the first test of this course, and then we'll create another one 2 weeks from now, and second test, and then here we'll create the last one, which will be the final exam, which will be in 4 weeks from now. So you better start preparing. All right, final exam. And so this syntax, the Prisma API allows us to work very easily with these relations. Now, let's log what comes out of this call. So course, and I'm going to run it. Oh, okay, unable to compile. It's missing. Oh, that's one of the beautiful things about Prisma is the type safety. So we're catching a lot of these bugs before they get to. The question I'm curious about is why didn't we get this in VS Code? Let's see. I'm just going to simplify the screens here. And so, course details. Is that a required field? Let's see. Oh, yeah. So we made that a required field. Okay, let's see if we restart the TS server, if we get that as an error. Oh yeah, there we go. We're already seeing the error. So sometimes when you're generating code, VS Code is not so quick to pick up on it. And then in such cases, you can use this restart TS server command, and then usually we'll get these errors. So there we go. We're missing these course details, and what we just saw now is a genuine developer mistake that gets caught by type safety. So I'm happy about that. Wait. Oh yeah, that was on the course. So course details, a soft introduction to CRUD with Prisma. We need another comma here, and then let's try to run that now. And okay, so we got back this course that we created, but we didn't get any of the related tests. That's a bit annoying. Well, what can we do about that? Well, the good news is that we have this include syntax, and include allows us to select additional fields. So by default, what we'll get is, I'm just going to open up the schema again, is we'll get all of these these scalar fields. And in this case, these are the three that we saw in the terminal: ID, name, and course details. In order to fetch relations, and this is actually a good thing because you have full control over what you're fetching. And as some of you may know, fetching relations can be expensive. So what we can do here is we can do include, and then we pass it an object. And we have the options of which related fields we want to fetch. And so we're going to fetch the tests too. And if I run this again, it will probably fail due to the unique constraint. Probably not, because the name or the course details don't have a unique. Nevertheless, just to reduce any possible confusion, let us delete first the tests and course. And so now when we run it, we should get back, as we saw before, the ID, name, and course details, but also an array here of all of the associated courses. And as we see, we have this updated at and this date. And then if we see, we have really a week from now is the 4th of August, the 11th of August is 2 weeks from now, and then we have 4 weeks from now, which is the 25th of August. So with that in mind, I'm going to pause here and look at some of the comments. And I want to wrap up in about 13 minutes, so let's see how far we can get if there are still any questions. Okay. No, there's no questions. All right. So let's go back. And I'm going to look at how we can associate also a teacher with this course in this single query that we have here. So remember, if we look here at the course, a course can have many tests, and it can also have many members. And the members, as you may remember, is a many-to-many, an explicit many-to-many. So this might look a little bit confusing, but bear with me and I hope that you will get this. So okay, so we define the test field, and now we want to associate the user that we created, Grace. I will actually name this Grace. So I want to relate Grace to this course as a teacher. And so if I just use the autocomplete, I have the option of defining members. But members is a course enrollment field. And so here I have the opportunity to create a row in this field. So this is what it will look like. I want to create, and then here I want to create a role. Teacher, user, but user in this case is a user field, so I have to do another relation, and I want to connect in this case because the user already exists, and that is Grace. And so here I have the option of, is that correct? I think it is, yes, email. And then I can take grace dot, see, everything is fully typed. In fact, this will actually also be typed. So remember when we added the tests to this query, course will actually have that as a type, and you can see that here below that it's I believe it's a union here of course, and another type which includes tests. Okay, so now we created a row in this course enrollment field through the members, and then connected that to the user grace. Okay, let's give that a go. But in addition to including test in our result, result set, I also want to get the members. And so here I'll pass true. And let's see, there is a way to... So members, you might remember, is pointing, yep. So we have the members, it's a course enrollment. And then what we're going to actually get in the result set is just the relation, the scalar field. So we're going to get the role, the created at, and these user ID and course ID. In order for us to get the actual user, we need to do something like include and then user true. And let's make this look a bit nicer. Okay. Now I'm going to run this again. And are we logging this after? Let's do that. Log that course. And there we go. So we have this as an object, so we can't see, but we can see that the user ID is 6. I have an idea. Why don't we look at another nice feature that Prisma has? So Prisma has got another feature called Studio. And in case you're not familiar with Studio, if you haven't heard of it, Prisma Studio is a visual editor for your database. So it's also an experimental feature that we have, but let's check it out, see what it can do for us. So, okay, it opened up my browser, and I'll move this to this screen. And what we have here is, let's open this up. So we have here all of the different models. So we have a single user, Grace, and we can look at her related courses. And oh, we see here that she's a teacher of, which course is that? Let's look at that. And that is, so if we're looking now at the course model, we see the members and the tests. If I double click that, then I can see, actually I think there's a tree view, which is a bit nicer to traverse relations. So let's start from a user and go to tree view. So we have this user, and then this user is associated with courses through the course enrollment, and she's a teacher of the CRUD with Prisma in the real world. And let's look at the tests of this. So really with this, you can fully traverse the whole, essentially it's a graph that is formed of all of the different relations. Okay, so that was all nicely created. Gonna close this. And now I wanna, let's see if we can, in the 7 minutes remaining to this stream, let's see if we can quickly cover some of the aggregation features. So, let's see. In order to aggregate, what we have to do is we have to create 2 students. So I've already prepared 2 pre-canned queries to create users, and there seems to be something wrong with them. Social is missing. I thought social was optional, but I guess I forgot to. So let's just add social. And David here. David and Shakuntala. And all right, so we created these two users. And oh, right, and we are associating them as students with this course that we created. The course, we have that here. In fact, we could do this through a nested write, but I think that would just make the first query too complicated. So I'm just going to keep it in this one. And so we created these two users. And now I want to add some test results for these. And so adding a test result for one of these would look something along the lines of, let's see. Equals, so Prisma dot test result dot create, and we start an object, and then we have data, and then here we start actually passing in all of the different fields. So we have the graded by, and then what we're going to do here is we're going to connect that to Grace. So we're going to take grace.email, and then we're going to do student. We want to connect that with, and if I hover over this, I can see also the different fields that are available. That's because it's all type safe, missing a comma here. And so we have the student, the graded by, and then of course it needs to be associated with a test. And then so we want to connect that with some of the tests that we created here. And because we included the tests in the result set of this query, I can actually just reference this course. So connect, and then ID, and then let's do course dot tests, and then because tests is an array, I'm just going to do the first one, and then use the nice optional operator just to prevent potential errors. I don't believe, actually I can't remember the name of this operator in TypeScript, but what it does is it prevents exceptions. And what are we missing here? Of course, we're missing the result, probably the most important part. And so result, and then let's say it was 950. Okay, so now we have that, and we have 3 minutes. I'm going to sort of race through this, and what I'm going to do is I'm going to create just an array here. With results for 70, and I am going to just add a loop to loop over this. So let counter equals 0, and then we'll do a for off, and then test of course dot tests. Remember, core dot test was an array, and we get that here. So I'm gonna counter plus plus, and what we'll do is we'll move this here, and we're gonna we're gonna seed the database with a result for each one of the tests. And then here, when I'm connecting the test, instead of pointing it to that one, I'm just gonna do test.id. And the result should be test results and counter. Okay, I think that should work. If it should, why don't we already go ahead and generate the aggregate query. Let's see. So after we finish that, const results equals await prisma.testResult.aggregate, and then here we pass it an object, and then we tell it where. And we want to do this specifically for the student, right? So let's look again at the Prisma schema to see which field we should use. Test result, right? So we have test ID and student ID. So we want to do that for Shakuntala. So here we'll use ID. Student ID is tala.id. You can use, for this where field, I think you can use any unique field. Yep. So for Shakuntala, we're going to get the aggregate. And what we want to get here is the average. That will be the average for all the tests that she has written. Result true. Quick reminder again that you can find all of this in the documentation, and then we want to get maybe the max and the min, and maybe even the count, just to and let's log the results, and we'll wrap up with that. And now I'm going to run the seed script. And, all right, yeah, I think it's the order of how I deleted them. And that should help. Oh, result, no. Okay, we can't leave it like this. And so, let's see. Let's open up quickly the CLI to see here. Or well, let's use the Prisma Studio to see what some of the data that we have in the database. So we have the 3 students. Let's look at this as a tree. And so we did this for Devi, courses, test results. Okay, so it looks like something went wrong with the test results. Perhaps we associated them. Nope. All right. So, I see what we did here. We forgot to put an await, and that's why it wasn't written. Let's see if this works. Oh, and there we go. Okay, so we got an average of 81.6, a max of 95, and a minimum of 700, which seems to be right. Just to be sure. 800 plus 950 plus 700. Let's divide that by 3, and yeah, indeed, we got the right answer. So that was it for today's live stream. We went a bit over time, but I hope that you found this useful. Sorry about all the screens here. Just going to remove the screen. So thank you all for joining us. We're going to continue with this series with a lot more streams to come. I hope you enjoyed this. If you have any feedback, feel free to reach out via Slack, Twitter, or using the chat. And see you at the next one.